Welcome back to part 2 of 6.1. So in part 1, we talked about perpendicular bisectors. In part 2, we'll talk about angle bisectors. So the definition of an angle bisector is a ray that divides an angle into two congruent parts. So let's just say I start with angle ABC. Then if I have the angle bisector of that, the ray that bisects the angle has to have the same endpoint as the vertex of the angle, and then it would divide that angle into two congruent parts. So let's just say ray BD is the angle bisector of angle ABC. Then that means angle ABD is congruent to angle DBC. It would also be the case that angle ABD or angle DBC is half the measure of angle ABC. One other way to put that is the measure of angle ABC is twice the measure of angle ABD or twice the measure of angle DBC. That's an angle bisector. Then for Theorem 6.3, the angle bisector theorem states this. If a point is on the angle bisector of an angle, so I'm going to use the same angle that I had in the previous example, angle ABC, and let's just say I have a point D. That's on the angle bisector of angle ABC. Then the point is equidistant, so that's the same term again, from the sides of the angle. So that means point D is the same distance away from ray BA as it is from ray BC. And then remember the distance of a point to a line, even though this is not a line, it's a ray, kind of the same concept, has to be a perpendicular segment from that point to, in this case, the ray. So these two distances would be the same. And then I just wrote out the angle bisector theorem in words. So similar to the perpendicular bisector theorem, Theorem 6.4, since the angle bisector theorem is written in terms of a conditional statement, is the converse of the angle bisector theorem. And before I write the converse of the angle bisector theorem, maybe you could write it on your own. Remember the converse of a conditional statement. You're just switching the hypothesis and conclusion. It should read something like this. If a point is equidistant from the sides of an angle, then it lies on the bisector of the angle. So I have a point, has to be on the interior of an angle. In this case, let me label that angle PQR. So if I have point M and it's equidistant from the sides, these two distances from M to PQ and M to QR, if those are the same distance, then it has to be true that M is on the angle bisector of the angle. On this example and the previous couple of other examples, I made an acute angle. It could be an obtuse angle as well. It could be a right angle. It could also be a straight angle. But regardless of what kind of angle you have, if a point's equidistant from each of the sides of the angle, then it has to be on the angle bisector.